Okay, y'all, welcome back. We are live. We are live. We live. Let's make sure my audio popping right. My phone on do not disturb. Mm-hmm. Let me see where we at with it. Mm-hmm. 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 Okay. Looks good to me. So we are going to tap in into the remainder of this video. So I'm share my screen with y'all. Share screen. There we go, people. Let's get it. Let's get into it.
There's no multiple ovals, just separate them with commas. And now notice a potential point of confusion. What's different about this comma and this one, just instinctively? Sort of minor detail, but important. Yeah. So one is inside, one is outside. So the one that's inside the quotes is literally the English grammatical comma that you want the human to see. The one out here is a C thing that's separating the first input to this function printf from the second. Strictly speaking, you don't need a space there, but it's a good practice stylistically to separate your arguments with single spaces, just as I've done there. So let me go ahead and now do something with this. Let me go back to my C code here. I'm going to clear my terminal window just to get rid of that distraction. And now I'm going to change answer to %s. And then outside of the double quotes on line 7, I'm going to do comma answer. And then after it auto saves, I'm going to go back to my terminal window. And just to make another deliberate mistake, /hello, enter. What's your name? David, enter. It's still broken. But why? I still have to recompile it. So again, you just get into the habit when you change your code, you have to recompile it so you get new machine code in the file hello. So let's do it again. Make hello, no errors is good, /hello, enter. What's your name again? DAVID. And now hello, comma, David. So again, a lot of this is still cryptic, but it's going to start to follow patterns like this. Functions like in math class, f of x, are written function name, parentheses, input, comma, input, however many you have. They're going to follow these patterns. But notice, too, on line 6 and 7, I have finished each of my thoughts with a semicolon. So what are the other commands that you can run in your terminal window besides something like ls? Well, it turns out there's a whole bunch of them. ls, of course, was simply short for list, which shows you the files in your current folder. But there's also cd for change directory, which is the command equivalent of like double-clicking on a folder to open it up in a graphical environment. There's cp, which is short for copy, which allows you to make a copy of a file or a folder. There's makedir, mkdir, which is short for make directory, which is how you could make a new folder. There's mv, which is short for move, which would allow you to move one file or folder from one place to another, or simply rename one of those to a different name. There's rm, which is short for remove, and there's rmdir, which is short for remove directory. So in fact, let's play around with a couple of these. Let me go back to VS Code here. Let me go ahead and open up my file explorer and recall that at this point, I've got two files, hello.c, which contains my source code, and then hello, which contains my machine code, the executable program that I previously generated by running make. Well, let me go ahead and propose that I'd like to prepare to keep all of my files and folders very orderly. So if like for every program I write or for every problem on a problem set I write, maybe I want to store my relevant files in a specific folder for that problem. So suppose then that I want to put hello.c in a folder, otherwise known as a directory, called hello. Well, I can't do that quite yet because I already have a program called hello. So let me use one of those new commands. rm space hello will delete or remove hello from my current directory. So I'm going to hit enter. I'm going to be prompted to confirm with y for yes or n for no, remove regular file hello. I'm going to hit y and enter. And as I hit enter, watch the top left of my screen as the hello file would seem to disappear.
Okay.
Voila, it's now gone. So now I'm going to go ahead and use a different command. Let me go ahead and do mkdir for make directory. I'm going to call the directory itself hello, and watch again at top left what happens. Enter. Now I have not a file, but a folder called hello. And in this GUI, the fact that it's a folder is indicated, 1, by its icon, and 2, by that little right-facing triangle, which means I can expand it to see what's inside. And in fact, if I do that, I'll see, of course, that nothing's in it because we literally just created it. All right, well, what if I want to move hello.c into the new hello folder? Well, I could, just like on Mac OS or Windows, I could actually, in my File Explorer, click and drag one into the other, but let's do this entirely within the terminal window. So let me do this. Let me move, or MV for short, my file called hello.c into a new destination folder, hello. And I can optionally put a slash at the end of hello just to make super clear that it's a directory, but that's not strictly necessary. But if I say mv hello.c hello with spaces in between, assuming hello exists as a folder, watch what happens at top left now. It's a little more subtle, but hello.c is going to move inside of the hello folder right now. And indeed, it's only slightly more indented, but notice if I collapse the hello folder, notice that it seems to be gone because hello.c is now inside of that folder. Of course, if I expand that, I'll see it again. If I go back to my terminal window and type ls for list, now I don't see hello.c, and I don't see an executable program anymore, but I do see hello. And the slash there just makes super clear to me, the user, that it's indeed a folder. So how do I change into that folder? Well, I can obviously use the graphical interface at left and click and expand and sort of see what's going on. But there's no direct connection between the File Explorer at top left and my terminal window at bottom right. Rather, those are just two different ways to explore the underlying system. So if I want to change my terminal window into this new directory, I can do cd for change directory, hello, and then enter. And now notice my terminal window's prompt changes slightly. There's still a $sign, which indicates type my commands here. But before that $sign, just so that I have a reminder, sort of breadcrumbs that visually remind me what folder I am now in, I see that I'm inside of hello. If I now type ls, I should see the file I expect to be in there, which is indeed hello.c.
Okay.
Now, suppose I want to try out some of those other commands, and suppose I want to maybe rename this file. I really want this file to be called something else, so maybe I might do something like this. mv hello.c space, and now a new...
Timeout. Take all these closed captions. I can't see. Hello. mv hello.c. So we're moving the hello.c.
name for the file. Well, maybe I want to make save this as like an old version of my code because I wanted to start fresh with something new. So I could do something like this: mv hello.c old.c, and watch what happens at top left. Hello.c, of course, gets renamed via the move command. So I can use move to move a file into a folder, or I can use it to rename a file or folder, as I've just done here. Now, suppose I want to undo that. Well, I can't just type undo. I can't just hit Control-C, but I can do the opposite in effect. mv old.c hello.c will now, per top left, change it back into that file. If I want to make a copy of this file, maybe as an actual backup, because I'm really happy with this version and I'm worried about breaking it, well, I could do cp for short. I can then do hello.c, and then I can do something like backup.c or any other file name. I'm taking care to use the same file extension so that if I do open this file later, it still opens and gets highlighted and colorized in the same way. But watch what happens now at top left when I type enter. I now have two files.
Why my captions keep popping up? So we did hello.c. We moved it. We renamed it. So mv. Put that in our notes. mv will move or rename a file. Cool. Then we're going to come back over here and we're going to listen to CP. What does CP stand for? Let's do a quick Google search. What I realized is I got to get good at typing without looking. In C coding language, CP generally refers to the Unix copy. So CP means copy. Let's put that in there. So what is it? Is that a function or is that a, what is that? Is CP and C coding? I gotta not look. Gotta not look. Language a function? No, CP is not a function in the C programming language. It is a command used in Linux. So these are commands, meaning you will use it in the terminal to copy files, not within the code itself. So, okay, what are commands? Let me just slow down. Commands in C coding language. Printf, getch. This function is being used to wait for the other's input. Return, get ch. Return, the C function returns 0 after terminating the C program. This function or method is block is closed with curly braces. Key features of C programming language. C is a general purpose computer programming language for system administration. So features may desire with these applications. Include this. Okay, so just wanted to have a couple of these. But still not really that still doesn't really explain it. So let's slow down real quick, y'all, because I should have been typing in here. I was typing in my other window. So let me move this real quick so I can make sure I get the right chat. And what I'm going to do is I'm going to find the correct chat, which will help me with this CS50 coding language. Okay, so we're just going to rename this one. Rename. CS50. Boom. Okay, put this back. Right there. Boom. Oh, no. That's not what I wanted at all. Let's move that back over here. Why is it even open? Move that back over here. We want this to be this. Okay, so we want, no, not that one. Keep that one over there. Keep that over here, my boy. We want this one. We want these two. There we go. Okay. So we're going to come down here. So now my question is, what is the difference between a function and a command? Period. For instance is make dir, comma, cp, comma, mv, comma, was it rm, comma, ls are these commands or functions. Let me clarify the differences between commands and functions. Commands are instructions you give directly to the operating system through a command line interface. The examples you listed, make, dir, cp, env, emails, are all commands. They are, okay. Functions, on the other hand, are blocks of code that are part of a program or script, can take input parameters, perform specific tasks, can return values, can be called multiple times within your code. To illustrate with an example, def calculate average num1, num2, return num1, num2. This is in Python. Okay, let me rephrase that. What are the differences between functions and command in the C coding language? I wonder why they have it start with C. I wonder if it's older. The commands, okay, here we go. Now it's doing it in C. The commands you listed, make, dir, cp, env, are actually Unix, Linux shell commands, not C functions. See, that's why it's important to be detailed with these LLMs. They're programs that run in your terminal command line in C programming. A function is a block of code that performs a specific task and is a part of your program. For example, integer add integer x and integer 1, return x plus y. So I'm guessing this means integer, which is number, is telling them to add the integers, integer x, and return x dot y. I'm still having a hard understanding what these curly braces are for, but we'll get there. However, C does provide library functions that can help perform similar operations to these shell commands. For make.dir function from system.stat.h file for operations, remove, rename, fopen for studio.h. The key difference is command make.dir ls are standalone programs you run in the shell. Functions are pieces of code that are part of the program. Must be defined or included from libraries. Okay, and what's a library, y'all? Library is a collection of code that someone else wrote for you. As you heard, all right, must be redefined or included from libraries are called within your code. Return values and for example, if you want to create a directory in C program, you wouldn't use make.dir command, but rather make dir. If you want to create a directory in a C program, you wouldn't use the make dir command. So when we're talking about a program, are we talking about like the code actually? So this is a program. And what is this called? What is this section of my command line called? Or this is my terminal. But what is this actual thing that? Okay, let's slow down ChatGPT or Claude. Okay, let's slow down. I'm picking up what you're putting down. However, I have no coding oh my goodness, experience, and I am taking CS50. I have a few questions. When you say program, are you referring to the code we actually I don't use my pinky when I type. I just realized that we actually type question mark. Also, when I am also what is is the area where you type code. The terminal I know. But what is the area where I'm entering? I guess it'll be functions, right? Functions and whatnot. Does that make sense? When we talk about a program, we're referring to the actual code you write that tells the computer what to do. And yes, the stuff you type. Okay, that's what I thought. So this is a program. This is a program right here, y'all. Wait a minute. Oh yeah, this is my cursor. I don't really need that right now, but we might keep that up. There are two main areas you'll work with: text editor IDE integrated development environment. This is where you type your actual code. In CS50, you might be using VS Code, Visual Studio Code. Think of it as a special Word document for code. This is where you write your functions and programs, terminal and command line. This is where you type commands like ls. It's like a control center where you can navigate folders and run programs you can use as compile. So this is the text editor right here, or the IDE. This is the terminal. Cool. But they probably call it something. The basic workflow is write code in the text editor, save it, use the terminal, compile, and run the code. Does this make sense? Let me know if you're explaining. Yeah, that makes sense. Thank you for breaking that down for me. Period. Man, where are my hands supposed to be when I'm typing this? Where's my right hand supposed to be? Where are my fingers supposed to be when typing? This is crazy. Well, I just have to figure this out, y'all, because I'm not about to be no slow coder, man. ASDF, I kind of already got that. That's my hands naturally, and the left hand should be JKL. That okay, okay. Let me look at this picture. Oh, damn it. Okay, chill, y'all. We're going crazy over here. ASDF JKL. So right hand. Oh, okay. So JH. So this one should be. Oh, okay. I see how they broke that down. So my middle finger is only supposed to really be hitting three keys. The I8, K, and then that. Okay. That's interesting. They should be putting that in this damn code, to be honest, in this damn course. How I type correctly, because I ain't about to be sitting here typing, you feel me, like crazy and slow, even though I'm going to have to. So this one should be. Yeah, that makes sense. Thank you for breaking that down for me. Okay. What do I want to say next? Can you no you go that's crazy. How are you supposed to do that? The O is supposed to be this figure, huh? Yep. Okay, that's interesting. Go over those. That is wild. That pink's supposed to be putting in work, man. The pinky be putting in work. Okay, here's the examples broken down. Text editor where you write your code. This is like VS Code and CS50. We write here. Okay, yeah. Terminal. What is what is INT space M A I N? Int main in simple terms is the starting point of every C program. It's like the front door to your house. Every C program must have it. And it's where your program begins running. Let's break it down. Int means the function will return an integer number when it's done. Main is a special character that tells C start here. This is what we want our program to do. This is saying program completed successfully. Every movie has opening credits. Every book has first chapter. Every C program has int, that main. That's where it begins. Okay.
In this hello folder. And indeed, if I type ls now, I can see exactly the same. So long story short, there's this whole list of commands, and even more than these, that allow you to manipulate the underlying system in exactly the same way that you and I have probably done for years by using a mouse and pointing and clicking and double clicking. But for now, let's undo all of this, because I haven't really written that many programs today. And I'm going to keep things simple today and keep everything in my same folder. So let's undo all of this. Let me go ahead and now remove backup.c, because I don't particularly care about that. I'm going to be prompted to confirm as much. Then let me go ahead and move hello.c out of this.
Timeout. How do I make that? Make back, or how do I copy it? Oh, I got to copy it. Let's go back. Okay, here we go. CP, hello, Which finger is this finger? Dot C. Okay, we got that popping. CP hello dot C. Back up dot C. Boom. Okay, so I copy that. So now we want to go RM space back. No. Back up dot C. Y. There we go. Ooh, okay, I'm getting nice with it, y'all. I'm getting nice with it. Call me Stevie Wonder of the keys.
This folder and into the original folder. And conceptually, the original folder is what we would call the parent folder, the folder that contains this hello folder. And the way you can specify the parent folder, like back up from whence you came, is with dot dot. So a single dot, as we've actually seen, dot slash hello, dot slash a dot out means execute a program in this directory, dot. But dot dot refers to your parent directory. So watch what happens at top left when I move this hello.c file out of this folder. It shifts a little bit to the left to indicate that it's no longer in that folder. I'm going to go ahead and type cd dot dot, which will bring me back, or even while clicking. But for now, let's undo the folder is what we would call the parent folder, the folder that contains this hello folder. And the way you can specify the parent folder, like back up from whence you came, is with dot dot. So a single dot, as we've actually seen, dot slash hello, dot slash a dot out means execute a program in this directory, dot, but dot dot refers to your parent directory. So watch what happens at top left when I move this hello.c file out of this folder. It shifts.
Oops. Good. MV. Hello. Damn. I get used to that. Hello. Then that would be that one. Hello. Dot C. Space. Oh, shit. I'm getting used to typing this new way, y'all, so bear with me. Did I put a space right there? I think so. So JKL. This. My hand don't go that way, though. That's the crazy thing. Like, man, how you supposed to put your fingers like that, bro? That's confusing. He got his hands all spread out, but like, it ain't really like that, though. Or maybe, I don't know, I'll figure it out.
Shifts a little bit to the left to indicate that it's no longer in that folder. I'm going to go ahead and type cd dot dot, which will bring me back to my parent folder. Or even more useful, especially if you get confused or lost somewhere within your folders, you can actually just type cd and nothing, and that will whisk you back to that.
My boy, what did you just do?
Now, suppose I want to undo that. Well, I can't just type undo. I can't just hit Control-C, but I can do the opposite in effect. MV old.c hello.c will now, per top left, change it back into that file. If I want to make a copy of this file, maybe as an actual backup, because I'm really happy with this version and I'm worried about breaking it, well, I could do CP for short. I can then do hello.c, and then I can do something like backup.c or any other file name. I'm taking care to use the same file extension so that if I do open this file later, it still opens and gets highlighted and colorized in the same way. But watch what happens now at top left when I type enter. I now have two files in this hello folder. And indeed, if I type ls now, I can see exactly the same. So long story short, there's this whole list of commands and even more than these that allow you to manipulate the underlying system in exactly the same way that you and I have probably done for years by using a mouse and pointing and clicking and double clicking. But for now, let's undo all of this because I haven't really written that many programs today. And I'm going to keep things simple today and keep everything in my same folder. So let's undo all of this. Let me go ahead and now remove backup.c because I don't particularly care about that. I'm going to be prompted to confirm as much. Then let me go ahead and move hello.c out of this folder and into the original folder. And conceptually, the original folder is what we would call the parent folder, the folder that contains this hello folder. And the way you can specify the parent folder, like back up from whence you came, is with ... So a single dot, as we've actually seen, /hello, /a.out means execute a program in this directory, dot. But ... refers to your parent directory. So watch what happens at top left when I move this hello.c file out of this folder. It shifts a little bit to the left to indicate that it's no longer in that folder. I'm going to go ahead and type cd ... which will bring me back to my parent folder. Or even more useful, especially if you get confused or lost.
CD ... Oh, no space. CD space ... Or yes. Oh, it's the space.
Lost somewhere within your folders, you can actually just type cd and nothing, and that will whisk you back to that original folder no matter where you are. So it's a nice shortcut, and it's a nice way of undoing any confusion you might have caused for yourself. Lastly, let's go ahead and get rid of the hello directory with rm dir hello enter, and that now disappears at top left as well. Now, what I was hinting at here, whereby I had my hello.c file in a folder, and I was moving things around and renaming things and backing things up, isn't strictly necessary because there's actually other features still inside of VS Code that you're welcome and encouraged to play around with. In fact, if I go to my so-called timeline at the bottom of my file explorer here, you can actually see that there's been automatic backups made over time of this file. So if you click through those backups, you can actually see different versions of the same file slightly in the past, which might save you the trouble of having to manually create files. And in fact, in the world of software development in industry, there's actually standard tools, very similar in spirit to what we've been using GitHub for, that allow you manually to make different versions of your code so that you can proactively keep track of all the changes you've made without manually renaming things as you might typically on your own Mac or PC. All right, let me clear my terminal window and ask if there are any questions. Yes, over here. Yeah, a really good question. If we had something other than a string of text, and we had an integer, would you still use %s? No, you would use something else. And indeed, %i is what we're going to use, and we're going to actually do that. Perfect segue to other.
What is %s again? Is it in my notes? %s. I don't have it in my notes. Well, let's do a quick one of these. Okay. What? I keep wanting to go up with that one, but that's this finger. What is, so this finger is, what is %? I don't even know where the hell the % sign was. So 5 %s. %s. Oh, see, I hate when they do that. %s is a placeholder for a string text, and C4 on that is what we call a format specifier. Here's an example. This will print hello, John. No, I've never played no Mad Libs. Hello, blank, where you feel the name, and in C, we write as hello %s. You'll commonly use it with printf when you want to print a name, print user input, print any text that might change. For example, string name equals Maria. Printf hi, print s, welcome to CS50, \n, name. This will print hi, Maria, welcome to CS50. There are other similar placeholders, .i for integers, whole numbers, .f for floating point numbers, decimal numbers, and single for single characters. So, okay. Let's just keep going.
Other types that C actually has. So up until now, we've been calling a string of text literally a string. And this is common in many programming languages, including Python and JavaScript. Strings in the programming world just mean text, whether it's 0 or more characters thereof. But C does have other data types, just a few of which we'll dabble with today, but you'll use more over time. We've already seen string, for instance, which is indeed a string of text. But let's focus as well on like an integer. As an aside, there's other types too. There's Boolean values, like true or false. There's chars, which are single characters instead of full phrases or sentences. There's doubles and floats, which are real numbers, something with a decimal point, the equivalent of fractions. And there's longs, which are integers, but like longer integers, even bigger integers than you might type by default. So let's focus on an int, because so many computer programs, of course, manipulate numbers in some way. So what?
Time out. Before we get into that, I'm going to take a quick break, y'all. We are about 40 minutes in. I just want to stay fresh with this, you know what I'm saying? So what we're going to do is we're going to get some of this music on there popping.
What can we do with this?
Okay. Make sure that shit was really there. And then we just gonna chill for a second. Okay, y'all, let's get back to it, man. Let's get back to it. Quick little intermission. We're gonna get back to it, y'all. Get straight into it.
Well, if we want to be able to get an integer, lucky enough, CS50's library comes not just with getString, but also getInt. So that's going to be a third function we now use in C. And we need to know these, what were generally called format codes. So that placeholder I called before %s is indeed for a string. If we want to place a integer inside of something we're printing to the screen, we are, in fact, going to use %i instead. So let's now actually use these building blocks, getInt and %i, to actually get numbers in some way to sort of solve a problem. Well, what problem could we solve? Let's introduce another concept from scratch and programming more generally known as conditionals, like those proverbial forks in the road. If something is true, do this, else maybe do this other thing. So in Scratch, we might have had a set of puzzle pieces that looked like this. If x is less than y, then say, or have the cat say, x is less than y. So it's sort of stupid program, but it just demonstrates how we have two variables, x and y, in the context of Scratch. We're comparing them with a Boolean expression. We're using a conditional to then conditionally say or not say this phrase here, depending on whether this question has an answer of true or false, yes or no. In C, it doesn't look all that different. It's a little more cryptic, but you say literally if. You use parentheses, similar to functions, but confusingly, by convention, you put a space after the word if. So you don't put spaces after function names. You do put spaces after words like if. And you use the parentheses to conjure up this weird trapezoidal-like shape. So there's no real keys that kind of conjure that. So C uses parentheses, like most languages. And then there's these weird curly braces, which at least in English, we don't use all that often. But they're there on your keyboard, English or otherwise. And they essentially allow us to create this sort of hugging shape to the puzzle piece. Anything inside of those curly braces is going to be equivalent to anything inside of this yellow hug that's sort of grabbing one or more pieces inside. So what do we put inside? Well, this part is straightforward. Printf, quote unquote, x is less than y, \n, semicolon. So nothing new here. The only bit of new code is this if construct instead. What if you have an if else? So a two-way fork in the road. This is what that looked like in Scratch. Same question. If x is less than y, then say x is less than y, else say x is not less than y. In C, the code is going to be set up initially like this. So two sets of curly braces to represent this pair of yellow bars and this pair of yellow bars. And what's inside of them, indented no less, just like our pseudocode last week, is two printfs. X is less than y, x is not less than y. So that's it. So the only new stuff here really is now the else keyword, which does not need parentheses because you're just saying else do this other thing. But what if it's a three-way fork in the road? And we'll stop after that. Here's a three-way fork in the road in Scratch. If x is less than y, then say this. Else, if x is greater than y, say this. Else, if x equals y, then say this. So this is a little more precise because now we're handling equality, not just greater than or the opposite. In C, it's going to look similar to before, but we're adding this element here. And at first glance, especially if you've never programmed before, it looks like I'm an idiot and I made a typo. What looks wrong? There's like two equal signs, like not a typo. So it turns out, recall from earlier, when we used the equal sign the first time around, we used it in the context of getting a return value back from a function, like the getString function handed me back the user's answer. So unfortunately, because humans decades ago decided, hey, let's use the equal sign to assign a return value from the right-hand side of a line of code to the left-hand side, we sort of painted ourselves into a corner and like, oh, shoot, what do we do when we actually want to test for equality of two values on the left and right? So what most languages, including C, do is use double equal signs. So you can say double equals or equals equals or whatever, but it is, in fact, syntactically correct. What's inside of these three sets of curly braces? Same idea, printf, 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 based on what English phrase you want to print out. So this code, both in Scratch and C, I'll claim is correct. It won't run because we still need like the other stuff, the equivalent of the when green flag clicked. But out of context, this code is correct. But there's a subtle weakness in design. And we'll talk a lot about this week and beyond. Correctness just means the code does what it's supposed to do. Design is more subjective, like how well have you written your argument in an English paper? How well have you written your code is design. This code is not designed as well as it could be because I'm doing more work than I need to. Yeah, and back. Yeah, I don't need the x equals y, but why, logically? Exactly. That's just a math thing. Like either x is less than y, or it's greater than y, or the third and final option is they must be equal. So it's subtle, but why would you bother wasting time writing a line of code and expecting the computer to run a line of code that is just going to answer a question that logically you could have concluded already? Because if x is not less than y and x is not greater than y, then my God, just print out x is equal to y, because you know at that point, logically, it's true. You don't need to waste your time or the computer's asking a third question unnecessarily. In reality, it's not a huge deal. No one's going to notice in the real world on a Mac or PC that there's this extra line of code, but it's a bad habit. Keep it simple. Don't write code that doesn't need to be there if logically you can conclude otherwise. So in fact, let's clean this up both in Scratch and in C. I can tighten this up, so to speak, use less code here, less code here. And honestly, if only statistically, the less code I write, the less likely I am going to make mistakes. So that too is probably a net positive overall. Writing less code is generally better than writing more code. Not unlike English essays too, perhaps. All right, questions about this feature of C, conditionals, and this syntax? Yeah. Oh, a really good question. And yes, jumping the gun, there are alternative ways to solve problems like these. And the question was, to summarize, when to use if, else versus what's called a switch statement. More on those another time. But this is going to be true in general in programming, not just C, not just in Scratch, but every language. There are going to be several, dozens, hundreds, an infinite number of ways to solve problems. Among the things we're going to teach you, though, is indeed how to do things well or better than you might otherwise. And we're going to introduce you eventually to another feature of the language that can even simplify this code too. So for now, let's actually use this then. So let me go over to VS Code again. I'm going to go ahead now and clear my terminal window. Down here, I'm going to go ahead and close the hello.c tab, just so that we're going to create a new program. And let's just do something a little simple using some operators, so to speak. And I haven't used this word by name, but it turns out that there's lots of operators that come with C, just like a lot of operators that came with Scratch for doing assignment, or less than or equal to, greater than or equal to, actually equal to, not equal to. Now, some of these are a little cryptic, but there's no easily found key on your US English keyboard, at least, where you can do less than or equals or greater than or equals. So what most programming languages do is you don't use a special symbol where there's like an angled bracket and then a line below it. You actually just use two characters. So greater than or equal is literally this. Less than or equal is literally this. We already saw that equals is this. And not equals is to use an exclamation point. So this too is a thing in programming. Using the exclamation point, pronounced bang, is how you invert logically certain things. So bang equals or not equals is how you would express exactly that idea. It's just a symbol on the keyboard that some human decided, let's use this one to invert the idea. But we're going to need one other thing for this program, specifically variables, which we've used already sort of because in Scratch we got one for free. We had that answer variable that stored the return value of the ask block. But let's consider in general how you can, and probably did for problem set 0, use a variable of your own, like keeping track of a counter or a score or the like. In Scratch, if you want to create a variable called counter, you can set it equal to some initial value like 0. In C, that code's going to look similar. You literally just write whatever name you want to give the variable, then an equal sign, and then the value you want to give that variable. And because the equal sign is the assignment operator, it will behave essentially right to left and copy the 0 into counter. But this isn't enough for C. Remember that you, the programmer, have to tell the computer, is this indeed a number? Is it a letter? Is it an image? Is it a sound?
Integer.
You have to tell the computer that this is an integer, otherwise written as int for short in C. But there's one other stupid detail that's missing, which is now semicolon to finish the thought here. But this then is equivalent to this in Scratch. Let's do another. In Scratch, if you wanted to increment the counter, that is add 1 to it, you could literally use this puzzle piece here and specify you want to add 1. In C, it's going to look like this. Counter equals counter plus 1 semicolon. Now, at a glance, this seems like a paradox of sorts. Like, how can counter equal counter plus 1? Like, I can't make that math expression true, but it's not math in this case. The single equal sign is assignment. So this means take the current value of counter, whatever it is, add 1 to it, and then copy that value from right to left into the same variable, thereby changing it from 1 to 2, 2 to 3, and so forth. This, though, is so common in programming to be able to increment or even decrement numbers by 1 or 2 or more, is that you can tighten it like this. This is the exact same thing, a little faster to type, saves you keystrokes, maybe less chance for error. Counter plus equals 1, semicolon, is the exact same idea. Better still, this is so common in C and C++ and Java that there's a third way to do this. To my comment earlier about solving problems in different ways, the most canonical, the most popular way is probably just to say counter plus plus semicolon, which literally automatically adds 1 to that value. Only works for 1. If you want to do 2 or 3 or some other increment, you have to use one of the other approaches. But this simply does the same thing as this. And if you want to invert it to -1, you change the plus plus to a minus minus instead. So again, just little things that we'll see and pick up over time. Invariably, you'll have to look them up or check the notes or look back at the lecture slides. But in time, this will get familiar if you are not already familiar. So let's consider just logically how we might implement this in code. Let's go back to VS Code here, and let me propose that we create a program called compare.c, whose purpose in life is just to compare a couple of values. I'm going to go ahead and proactively.
Okay, code. Compare. Ayo, that's crazy. No, it's this JK dot CA. Okay.
Based on the previous chats, include CS50's library from the get-go. I'm going to include.
My boy typing fast. Shift 3. Shift 3. Then we want to go include, so we're going I N. Oh no. N C L U D E. This is crazy typing like this, yeah. CS 50 dot H shift. So it'll be like that. Period. Okay, period is at JK. Okay. Enter. We're gonna go INCLU DE shift curly JK C. So it'll be this one C. So we're coming down, we're coming with the middle finger on the right and the left hand. And S would be that next to the pinky. 50, 5, 50 dots. So we come with this one. H, that one. Shift, dot, enter. Oops.
Standard io.h from the get-go, so I can use getInt and printf respectively. I'm going to just on faith type int main void. And today we won't explain what that does. More on that to come. For now, just assume it's like when green flag clicked. But in this program, let's do a couple of things. Let's declare an integer called x and assign it the return value of getInt. And let's just keep it simple. Let's ask the user not what's their name, but what's x ? Semicolon. Now, so that we have something to compare, let's do it again, but with y. Int y equals getInt, quote unquote, what's y ? And I'm leaving again a space just visually so the cursor nudges over a bit, followed by a semicolon. At this point in the story, my users will be prompted for x and y respectively. Let's do something with those values. How about if x is less than y, then go ahead and print out, quote unquote, x is less than y \n, close quote, semicolon. All right, and let me hide my terminal window for just a moment.
My boy typing fast. Okay, int. Ooh. Int x equals. Damn, nigga typing slow as fuck. Equals. Let's stay focused though. Let's stay focused. Get underscore int x equals get. Which one is underscore? Okay. So what finger would that be? That'll be. Damn. What's X? You want to hit that with the there or space. Okay, I messed up somewhere. Way right here. What's X? Then we want to hit it with the other parentheses, semicolon. Then we want to hit int space y. Oh my god. I'm pressing enter. Okay. Equals. No. Int y. Equals. See, this is so much easier. I'm just so used to typing how I've been typing. Trying to fix my typing is like crazy. Okay. Underscore int parentheses. One of these. Oh, I need to hit the shift one of those. Get touch and what is this called? A quote? Yeah, quote. Quote. Oh, shift. That's why I keep fucking up hitting enter. Shift. Okay. Then we hitting the what's. What's y? Question mark. And then we hitting the end quote. Hitting the 0. Boom. Semicolon. That's a regular colon. Semicolon. Then we hitting the if x is greater than y. Yep. We want to hit that, and we want to hit a motherfucking another curly braces inside Enter that. Print F parentheses. We want to hit quote. X is less than Y. X is less than Y. Backslash. In. Oops, that's not no backslash. Backslash. In. Semicolon that up. And yeah, let's see. That should look good, but I'm getting an error here because this is supposed to be one of these. Boom. All right.
The moment, this is a 13-line program at the moment, but return value of get int, and let's just keep it simple. Let's ask the user not what's their this equals 1 semicolon is the exact same idea. Better still, this is so common in C and C++ and Java that there's a third way to do this. To my comment earlier about
ham on this thing.
I ain't gonna lie, man. The most canonical, the most popular way is probably just to say counter plus plus semicolon, which literally automatically adds 1 to that value. Only works for 1. If you want to do 2 or 3 or some other increment, you have to use one of the other approaches. But this simply does the same thing as this. And if you want to invert it to -1, you change the plus to a minus instead. Okay. So again, just little things that we'll see and pick up over time. Invariably, you'll have to look them up or check the notes or look back at the lecture slides. But in time, this will get familiar if you are not already familiar. So let's consider just logically how we might implement this in code. Let's go back to VS Code here, and let me propose that we create a program called compare.c, whose purpose in life is just to compare a couple of values. I'm going to go ahead and proactively, based on the previous chats, include CS50's library from the get-go. I'm going to include standard io.h from the get-go, so I can use getInt and printf respectively. I'm going to just on faith type int main void. And today, we won't explain what that does. More on that to come. For now, just assume it's like when green flag clicked. But in this program, let's do a couple of things. Let's declare an integer called x and assign it the return value of getInt. And let's just keep it simple. Let's ask the user not what's their name, but what's x question.
I think I messed up right here on line 8, but let's see what we got going on.
Semicolon. Now, so that we have something to compare, let's do it again, but with y. Int y equals getInt, quote unquote, what's y question mark. And I'm leaving, again, a space just visually so the cursor nudges over a bit, followed by a semicolon. At this point in the story, my users will be prompted for x and y respectively. Let's do something with those values. How about if x is less than y, then go ahead and print out, quote unquote, x is less than y.
Why my code don't look like his code?
Backslash n,
let's just see what happens.
Semicolon.
We'll debug it.
All right, and let me hide my terminal window for just a moment. This is a 13-line program at the moment, but really it's like 5 or 6 interesting lines. The rest has been copy-paste from previous programs. Notice a few details. One, I've indeed used my curly braces here. And notice if you highlight lines, you'll actually see little dots that can help you make sure, oh, there are indeed 4 spaces there. I've been indenting, just like we did last week with pseudocode. Strictly speaking, it's not necessary, but it's going to be way easier to read your code if you do add all of this white space, so to speak, than if you write and then submit to us as homework a program that looks sort of god-awful like this, which is going to make it much, much harder for the human to read it, for you to read it, your colleagues in the real world to read it, but the computer is actually not going to care. In fact, as an aside, one of the tools we have built into VS Code for CS50 is this button at top called Style50. This is a program that we indeed wrote that will give you suggestions on how to improve the style of your code so it looks like the right way that programmers would generally write it. As an aside, the computer world is fraught with like religious debate, so to speak, as to like what code should look like. And people in the real world will have really stupid arguments over how many spaces to use for indentation and what lines code should go on and so forth. Generally, in the real world or in a class, there's an official style guide that someone sort of autocratically declares this is how everyone should write their code, so that just everyone's code in the company or course looks the same. But you'll find in the real world, reasonable people will disagree. When you click Style50, it will be formatted as we ourselves recommend in CS50. And in fact, let me zoom out here And this looks a little cryptic at first glance, but on the left is the code that I just wrote and made a mess of by deleting.
Okay, well, time out. Okay, there we go. Okay, on the left is the code that I made a mess of. And on the right, so my whole thing in red. My whole thing in red, y'all. All right, well, let me get this back to where it was. Put this back over here like this. How do I pull that thing over here? Swap left and right side. How do I just make them both sit next to each other? Don't know. I think I just got to go full screen with it. But I want to just slide this over a little bit. Can I do that? Show leading space split editor, right? Oh, there we go. I think that's the way I want it. Maybe not. We'll just go full screen with it. Let's see. Let's go to explain changes. Quack, IMC50's duck debugger, DDB. Explain changes. Changes are made at the following lines. Line 4. Let me wait till it's done because it's not letting me scroll up. Line 4, the space between main and void is removed. Okay. Why? Before and main. Void, after, and main. Okay. Why is it removed, though? I guess this is what it's supposed to be, so we'll hit that back like that. Line 67, the spaces inside the parentheses of get underscore in are removed. Line 6 and 7. Okay, so I can just bring that straight up in there. Like so. That can just be up in there. Line 9. If statement is indented and a space is added around the comparison operator. So we got this indented and the space before and after the operator. Like so. Line 11. Print F. What's going on with printf? Printf statement is further indented. Whoa. Printf x is less than y equals n. Say it again. Line 11. The printf statement is further indented. 2 indentions? Why though? Okay. Why did we remove? What do we remove? The space for line 1 is just a neat thing, and then this one should be right here, like that. And I don't need this. For line 1 and okay, well, we'll just keep it like that. Okay, well, Style. I like that. You gotta have the code looking neat, y'all. That's the thing apparently. Why can't you like this, huh? Put it over here. So we good.
All that white space. On the right is the way the code should look if it is well styled. So whereas correctness is all about, does the code work the way it's supposed to? Design is about, how well have you written that code? Is it efficient? Did you make good decisions? Style is purely aesthetic. Is it readable? Does it follow a standard? Can another human sort of easily skim it top to bottom, left to right, and understand what's going on? So these green highlights are saying, please add white space there. And so I can actually change my code to match. On the left-hand side here, if I realize, oh, my code's looking pretty ugly, watch on line 6 at left as I hit the space bar to, whoops, sorry, on the left, 1, 2, 3, 4. Notice that the right-hand side is starting to be happier with my code by getting rid of the green indicators. And I can do 1, 2, 3, 4. That fixed that. Over here, I can do 1, 2, 3, 4. I can move this onto its own line by hitting Enter. And you know what? If it's taking too long, once you get into the habit of things, you can just apply changes. It will give you the suggestions automatically, and we're done and on our way. But for practice's sake, I would get into the habit of doing things manually until it gets boring and tedious, and at which point you might as well automate the process with a single click. All right, so let's actually run this code. I'm going to go ahead and open my terminal window again and clear it for clarity. I'm going to run make compare and hope that I didn't make any mistakes. I don't seem to have yet. /compare. And now notice I'm prompted for x, let's type 1. For y, let's type 2. Enter. And x is less than y. Let's do a little sanity check, so to speak. Let's rerun it.
My boy, he went through that fast. Okay, 107. Let's go back a little bit.
But for practice's sake, I would get into the habit of doing things manually until it gets boring and tedious, and at which point you might as well automate the process with a single click. All right, so let's actually run this code. I'm going to go ahead and open my terminal window again and clear it for clarity. I'm going to run make compare and hope that I didn't make any mistakes. I don't seem to have yet. /compare. And now notice I'm prompted for x, let's type 1. For y, let's type 2. Enter. And x is less than y. Let's do a little sanity check, so to speak. Let's rerun.
What's x? 3. What's y? 9. X less than y. Oh, look at me. I got these integers popping, y'all.
Run it. /compare. What's x? Let's do 2 this time. 1 for y. And this time it said nothing. So that's to be expected, because I didn't have a 2-way or a 3-way fork in the road. The only time this code should say anything is if indeed x is less than y. So for those of you who might be more visual when it comes to learning, here's a flow chart that represents this same exact program. If you read it top to bottom, you start the program with /compare. You are then prompted for x and y, and you're asked this: is x less than y? And the fact that this is a diamond means this is a Boolean expression, a question that the computer is asking itself. If the answer to that question is true, then quote unquote x is less than y gets printed and the program stops. Else, if x is not less than y, as in the second scenario, the answer is, of course, false, and nothing more happens. But we can build out this tree, so to speak, by adding a bit more code. So let's make it look like the second Scratch example. If I go back here, it's not hard to just say else if x is not less than y, let's say that.
Okay, so right here, enter curly braces. Else hold on. Else. Oh no. How do you do that so fast? My boy be typing fast.
Or C == capital N. So read. So this is now left to a variable, which I could call answer again, but honestly faster by taking alternative arrows based on true. Keyboard shortcuts, you can just go up, 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 and that will go through all of your previous commands, at which point you can just hit enter. It's greater than y. Once more time, /compare. So for those of you who might be more visual when it comes to learning, here's a flow chart. Go back here. It's not hard to just say else if x is not less than y, let's say that. Or C == capital N. So this is now left to a variable, which I could call answer again, but honestly faster by taking alternative arrows based on true. Keyboard shortcuts, you can just go up, 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 and that will go through all of your previous commands, at which point you can just hit enter. It's greater than y. Once more time, /compare. So for those of you who might be more visual when it comes to learning, here's a flow chart. Else, if x is not less than y,
Okay, y'all. This is going crazy. My boy going crazy with the. My boy going crazy with the. Okay. Okay, y'all. Let's. I need my boy to slow down. Literally. If I was in this class, I'd be getting cooked. Bruh. I gotta click it.
let's type 1. For y, let's type 2, enter, and x is less than y. Let's do a little sanity check, so to speak. Let's rerun it, /compare. What's x? Let's do 2 this time, 1 for y, and this time it said nothing. So that's to be expected, because I didn't have a 2-way or a 3-way fork in the road. The only time this code should say anything is if indeed x is less than y. So for those of you who might be more visual when it comes to learning, here's a flow chart that represents this same exact program. If you read it top to bottom, you start the program with /compare. You are then prompted for x and y, and you're asked this: is x less than y? And the fact that this is a diamond means this is a Boolean expression, a question that the computer is asking itself. If the answer to that question is true, then quote unquote x is less than y gets printed and the program stops. Else, if x is not less than y, as in the second scenario, the answer is of course false and nothing more happens. But we can build out this tree, so to speak, by adding a bit more code. So let's make it look like the second Scratch example. If I go back here, it's not hard to just say else if x is not less than y, let's say.
Okay. So we got curly braces. So we got the semicolon, curly braces, else. Got an extra one right there. We delete that. Else. And then it's right there. Oh, it's this one needs to be replaced with this one. Else. Okay, 108.41.
This tree, so to speak, by adding a bit more code. So let's make it look like the second Scratch example. If I go back here, it's not hard to just say else if x is not less than y, let's say that.
How did he do that? Oh, so this one was already ended. So yeah, I had that right. So we're gonna come here, delete this. Boom. Else. And then we come over here, curly braces. Print F parentheses one of these x is no. Print F. What's next?
X is not less.
Okay, we come here. X, that was a 40-minute timer, is not less than what?
Less than y backslash n, close quote, semicolon. Let me now go ahead and rerun, make, compare, enter, / compare, enter. And again, I'll do the second example. 2, which is bigger, and 1, which is smaller. And this time, I will see x is not less than y. If then we were to look not at this flow.
My boy, slow down. What is X? 69. What is Y? 32. X not less than Y. Did he do that?
Go back here. It's not hard to just say else if x is not less than y, let's say that. X is not less than y backslash n, close quote, semicolon. Let me now go ahead and rerun, make, compare, enter, / compare, enter. And again, I'll do the second example. 2, which is bigger, and 1, which is smaller. And this time, I will see x is not less than y. If then we were to look not at this flow chart, but a slightly bigger one, you can sort of visualize it this way.
Okay, it might be time for another Rizake. Time for another break. All right, y'all. I'm gonna come back for part 2. We did a minute and a half, or hour and a half today. I'm gonna get through this video. I just need to take a break. All right, y'all. I'm gonna take a break. I'll tap back in with y'all in a second.